Okay, we will start working on the CAM simulation. It's very important that we already have the assembly done. So I have the CAM here and I have the follower here. So the first step is to go to File and go to Motion Simulation. That's very important. First of all, go to Motion Simulation, select it, and you will see that all the uh, icons for motional will be coming into screen. Okay, in this case I already have Motion 01 here, top left, because already this one's already done during class, so I'm going to erase it, delete it. So we can have another case. So I left click on the name of the assembly, right click on it, new simulation. Then it is coming now, new simulation. It's very important we select dynamics and C1 underscore motion underscore 01. Okay. Then it's very important to create links and joints. So in this case, we're going to be working on the skeleton, so it's very important also. Go to show and hide option, show and hide, and we will hide the solid bodies. Okay, and then go to link. Link, select link, and we're going to create the CAM link, selecting both the profile of the CAM and the inner circle, which represents the basic radius of the CAM. Then let's go to center of mass, making sure you have this icon of the circle selected. So you select this circle, and using this icon that says coordinate system of the object, select once again the circle, and in mass, well, it has 0.99 pounds. I'm gonna change it for 1, and then 2, 2 and 2 as values of the parallel inertial moments, and orthogonal inertial moments will be 1, 1 and 1. Then the name of the first link will be C01 CAM C01. Apply. And for the next link will be circle, circle, and line. Only select these 3 lines. The first 2 are going to be circles, and then the third one is going to be a straight line. Then center of mass. Once again, make sure you have this icon selected. So click on the circle, this one. So we're going to have the center of mass exactly here, and then coordinate system of inertia will be selecting once again the circle, change the mass to 1, 2, 2 and 2 for the parallel moments of inertia, and 1, 1 and 1 for the orthogonals. Then we change the name to CO2 follower underscore 02. Apply. Okay, you can see here this is the name of the CAM as a link, this is the name of the follower as a link. Cancel. You can open the links or expand the option of the links, and we have 2 links. Then let's go to joint. Okay, and make sure you go to revolute. So you select this circle, because it belongs to the cam. You will see that when you select the circle, it's also highlighted the profile of the cam, because I am selecting the link belonging to the cam. But since I am selecting the circle, the computer uses the center of the circle for the origin. It's very important to change this motion to the positive direction of the y, or in this case the x, the y, excuse me. And the vector is already selected, because when I select the circle, it creates a vector perpendicular to that circle, exactly on the center of the circle. Okay, display scale will be 3, because that way it's much easier to see the icon of the Revolute. And then we're going to type 01 rev, or we can rev from Revolute. Apply. You see, this is the icon for Revolute. And then let's go to select this line, but make sure you changed the option to slider. Click the line, and you will see this is the vector. And there's something important here. You see that the center of mass, or the origin, it's in this circle. We need it here. So specify origin, go to circle, click on the circle, and the vector, it's here. It's okay. We need this vector on this position. Display scale for the case of slider, it's also 1. So we type 02 underscore SLD follower. Okay. Then you see the new icon. Part of the files we have, remember, one of them has to be there. Excuse me. Okay. The file with the values of the S. Okay. S versus time. Time, since we are having a 0.5 revolutes per second as the velocity of the cam, so every 2 seconds we have a full revolution, and we need the time that the cam spends on every degree. So we divide the time, 2 seconds, over 360 to have the time for every degree. So we have the column that represents how much time the cam spends with an increase of 1 degree. Okay, that's it. So having that into your computer, let's go to expand the options or the joints and double click on cam, Revolute, driver, and make sure you go to constant, and then in the initial velocity make sure you are selecting revolutes per second. That's very, very important. Many of the problems is that some of you already maintain degrees per second or revolutes per minute. It's revolutes per second 2. Okay, so you already have this red changed into the icon, means that we have an actuator here. Okay, double click on the follower and then go to driver and then go to function, and in function you have to go to function manager on the blue arrow here, and then table in AFU, you select a new one and you can type 01 slider follower motion. That's the ID of the equation. And then go to the third creation step, XY data. In this one, in the X increment, you have to type 2 seconds over 360 and the number of points 360. Once you feed this information, you go to key in from text editor, delete what you have there, and copy the values from 0, these two columns from T versus S, 0 to 359. Okay, right click, copy, and then let's go to the next, paste them. I delete the last space, paste them into the key in table, click OK, and then just make sure here on your edit data have the same values that you already fed. Select OK, and then OK. Once again OK, you see that it is highlighted in blue, the last equation you created. Okay, and then OK. Next, you go to the case of motion, left click first of all, and then right click, new solution, time 2 seconds, 100 steps, solve with OK, and type 01 underscore solution underscore 01. OK. That's it. So you go to animation, okay, and then make sure you have this loop icon selected, and you can click play to make sure it is moving. Something wrong here. Let me see what's going on here. Okay. Driver 2 revolutions per second. No, excuse me, 0.5 revolutions per second. I made a mistake. Not 2 revolutions, 0.5. Okay, once again, solve solution number 1. Okay, animation again. Okay, now we have it. Okay. Let's see from view. Okay, closed. Then let's show the solids. Double click on cam 01 and select cam. So you will see, instead of having 2 selected objects, you can have 3. Click OK. Select the follower. Double click. Click on the circle. Click on the bar. Select also the internal shaft. You have 6 objects selected. Okay, click OK. View geometric, view front, go to show and hide sketches and hide curves, and then once again home, animation, play. Okay. Remember, there's no problem if somehow the cam intersects a little bit the follower, because we are talking about the mathematical following, which can be corrected later using some other types of followers. But anyways, that's a very important simulation I'm interested in for your second partial exam. Thank you very much.